Good morning, students. Till last session, we have studied about Bohr's atomic model, and now we are going to study developments leading to Bohr's model of atom. That means कि ऐसे कौन से developments आए थे और what theories were proposed that lead to the success of Bohr's model of atom. So, because before Niels Bohr there were many scientists who examined about the particles present in atom or the movement of these subatomic particles, but Bohr's model of atom was the most successful in explaining the position of electron, in explaining the neutrality, in explaining the energy levels, because the concept of energy levels or energy shells was very new before Niels Bohr's model of atom. So we can say that historically results observed from the studies of interactions of radiations with matter have provided immense information regarding the structure of atom and molecules. Now look at this. There are few new terms for us that needs to be inculcated here in order to have a better understanding of this model. First is interaction of radiation. Radiation, we all know that from anything, if rays are emitting out or if rays are absorbed, we call it as radiation. Interaction of radiations, we will study how they interact with matter. Matter, you all know, anything which has mass and occupies space. Now, Niels Bohr utilized these results to improve upon the model proposed by Rutherford. Before Niels Bohr, the most successful model was Rutherford, but after Bohr's model of atom, the most successful model of atom was Bohr's model of atom, and there were two developments. First was dual character of electromagnetic radiation. Since the term electromagnetic also consists of two important terms, electro plus magnetic, means electro, something connected with electricity or electrical current, and magnetic means something connected with magnet. Dual character means it will display two functions or it will display two properties simultaneously at a single time, which means radiation possesses both wave-like and particle-like properties, right? So experimental results regarding atomic spectra was also one of the reason. Like if atom is given extra amount of energy, with what kind of radiation it will emit, or when it absorbs extra amount of radiation, it reaches to higher energy level, and when it again bounces back to its normal state or ground state, what kind of radiation it emit back. So radiation that are absorbed and radiation that are emitted, that can be included in the atomic spectra. Now look at the diagram. This is displaying wave nature of electromagnetic radiation. Now as I told, there are two fields with us, electric field and magnetic field, and we can see that the red line is consisting of electric field component and the blue line is consisting of magnetic field component, and we are taking three coordinates x, y and z, means in three-dimensional space we are observing the pattern of flow of electromagnetic radiation. So electromagnetic radiation are basically radiation in which electrical field and magnetic field are perpendicular to each other. We can say agar electric field is moving at 90 degree, the magnetic field will be moving, right? And they both will move in the same direction. ऐसा नहीं है कि electric field will move right and magnetic field will move left. They both will move in the same direction, but they will move with a distance or with an angle of 90 degree between them. So James Maxwell was the scientist who gave this theory or wave nature of electromagnetic radiation. He said that waves travel in the form, electromagnetic radiations travel in the form of waves. What kind of waves? These two kind of waves. So look at this written here, the electric and magnetic field components of an electromagnetic wave. These components have the same wavelength. Wavelength is the distance. You can see we are going to study the factors and the various physical properties of the waves. Then you will become more clear with the terms wavelength, frequency, speed and amplitude, right? So the consecutive distance between two waves is wavelength. Frequency is the amount of waves or number of waves passing through a single point in 1 second is known as frequency. Speed, you all know, we all are well acquainted with the term speed. Then comes amplitude. Amplitude क्या होता है? You can see here लाइन से ऊपर, above the line there is a portion hill type or mountain type, this is known as crest, and below the line ये जो inverted hill type portion है mountain type, this is known as trough, TROUGH. So this is crest above the line, this is trough below the line. So the distance or we can say the height of the crest, यानी कि crest की कितनी height है, और the depth of the trough is known as amplitude. Fine. So we are clear with these terms: wavelength, consecutive distance between two waves, frequency, number of waves passing through a single point in 1 second, speed, how fast the waves travel, amplitude is the height of the crest or the depth of the trough. But they vibrate in two mutually perpendicular planes. As I told, they both have different planes which are at 90 degrees to each other. Now comes properties of electromagnetic waves. Now properties में सबसे first and important property is that they are perpendicular. First point. Then unlike sound waves or waves produced in water, electromagnetic waves do not require any medium and can move in vacuum. We all know that sound always needs some particle or needs some medium to travel, right? But electromagnetic waves do not require any kind of medium. They can travel on their own. They can also travel in vacuum, because we know in vacuum there are no particles and there are no atoms, nothing is there in vacuum. So these electromagnetic waves can also travel in vacuum. Now it is now well established that there are many types of electromagnetic radiation which differ from one another in wavelength or frequency. These constitute what is called electromagnetic spectrum. Now we have different kind of waves with different wavelength and frequency. So depending upon the wavelength or frequency, because हम ये नहीं कह सकते for example अगर मेरे पास कोई स्पीकर है उससे कोई साउंड वेव आ रही है तो उन वेव्स की वेवलेंथ, और मेरे पास अगर कोई एक छोटा सा डिवाइस है टॉय टाइप, उससे अगर थोड़ी सी वॉइस या वॉल्यूम मैं कर दूं उसकी टॉय की, तो वहाँ से जो साउंड आ रही है, तो स्पीकर की साउंड एंड द टाइनी टॉय की जो साउंड, दोनों की वेव्स अलग तरह की होगी. And now if waves are different, the wave properties will be different. So I can say that waves always many types of waves differ in wavelength or frequency, and that's why they constitute electromagnetic spectrum. Electromagnetic spectrum में अलग अलग तरह की waves are arranged on the basis of increasing or decreasing pattern of wavelength or frequency, right? So there are different regions of spectrum which are identified by different name. Radio frequency is the region around 10 to the power 6 hertz. Hertz is cycle per second. One cycle means one crest and one trough एक point से pass हो जाए, that is one cycle, ठीक है. And cycle per second को we call it as hertz, HERTZ. This is the term, this is the unit used for the frequency. So radio frequency region is around 10 to the power 6 hertz. Microwave region is around 10 to the power 10 hertz, used for radar. Infrared radiation are used for heating. UV radiation, we all know it's component of sun's radiation. The small portion around 10 to the power 15 hertz is visible light that we can see or detect, and special instruments are required to detect non-visible radiation. Because have you ever noticed that are we able to see UV rays or infrared rays or micro rays? Never, because we need special kind of instruments for seeing this. What we can see is only visible light. So we can say that our human eye is able to detect waves with around 10 to the power 15 hertz frequency. Means this is the frequency range of human eye that we are able to detect. So this is the diagram that we are going to see. This is electromagnetic radiation or electromagnetic spectrum. We can see gamma rays, X-rays, UV rays, IR, microwave, FM, AM, long radio waves, and in the middle of UV and IR we can see there is a small line. If we examine the small line on a broader scale, then we can see a visible spectrum is observed. VIBGYOR, we can say this is the region, or this is the phase which human eye can detect. So visible spectrum is around 10 to the power 15 hertz. और अगर हम lambda मतलब कि होता है wavelength have all the units of that we use in measuring distance. यानी distance को measure करने के लिए whatever units we are using, we can use that for lambda also, because lambda means wavelength. If we are measuring length of anything, we are going to use the same units of distance, so we are taking it as meter. So meter, nanometer, like this. Nanometer is 10 to the power minus 9 meter. So visible spectrum is from 400 to around 750 nanometer. It comes between UV and IR, and we can see that on the top there are units according to frequency. Frequency is V-shaped symbol known as nu, and frequency is measured in hertz, and wavelength is measured in lambda, and it is its unit is meter. So these are different types of radiation waves. We all are well aware with X-rays, UV rays. X-rays are used in, you all know that X-rays that are used in medical purposes, microwaves. FM rays are used as radio waves. So these are different types of waves with different wavelength and frequency, and when we arrange them in a well established order, then we call it as electromagnetic spectrum. And visible spectrum is a part of this electromagnetic spectrum with a frequency around 10 to the power 15 hertz and wavelength around 400 to 750 nanometer, and 1 nanometer is 10 to the power minus 9 meter. So that's it. That was all for today. We will come in our next class with a different topic. So I want from all of you to read till now from the NCERT textbook, so that you can have the clear idea of what we have read today. Thank you so much.